So, hi everyone. I'm really excited to be here today to deliver this ambitious event in support of the UK aircraft interiors sector. We have some amazing speakers and fantastic breakouts in store for you today. So the aim of the day is to disseminate some clear strategic insight to inform your business, and through the engagement of the breakouts later, see new technology collaborations that may lead to ATI grant-funded projects. If you haven't heard of the ATI, we basically act as a technology collaboration hub, think tank for UK Aerospace, sitting at the juncture between industry and government, and delivering £150 million a year of grant funding for aerospace R&T. We also launched Fly Zero, which you might have heard of, which also is working closely between industry and government, and which also gives you a flavour of what else we get involved in. ATI funded projects require clear technology innovation from TRL 3 to 6, as well as a strong business case with a clear route to market and UK economic value add. So we started our UK aircraft interior strategy development by leading an investigation and publishing an insight on the UK cabin opportunity. We delivered this work in collaboration with Achieving the Difference and Cranfield University, who each brought tremendous value to the study. The work included evaluation and capability assessment of the UK supply chain, a global market forecast to understand the value of key systems and technologies for the UK. Crucially, we also needed to understand whether the cabin supply chain faced significant barriers to innovation and bringing new technologies to market. So I'll highlight some of the key analysis and findings in the next few slides. In 2019, the aircraft interior sector was a $19 billion industry per our analysis, with strong growth due to our previously thriving retrofit market in addition to new aircraft sales. The forecast, we forecast greatest growth in connectivity systems, IFE, in-flight entertainment, which was primarily driven by the retrofit market and aftermarket sales. Seats, galleys, monuments, lighting also showed really strong growth with 3% year on year through to 2038 as per our forecast. These markets have taken a major hit, unfortunately, as OEMs cut production and airlines cut discretionary spend. I show here ATI's initial estimate on the impact of that forecast, unfortunately seeing 15% wiped off the market value over the next 20 years. However, there's hope, and we're investing now for a recovery, and that's why we're here today. Ben Battelle from Counterpoint will be elaborating on the current state of the aircraft interiors market at around 11:45. So we have a great breadth of capability and diversity across the UK and a huge amount of innovation potential across our local ecosystem. The UK supplies approximately 10% of aircraft interiors products, with an unparalleled concentration of industrial design organisations centralised in London. We supply over 30% of the world's aircraft seats, along with great capability across other cabin furniture, lighting, connectivity, galleys, cabin air and electrical power systems. So I'll just flash up here the innovation barrier study that we did. So please look at our insight for more details. And also the brief technology analysis that we did, looking at the key technology themes which land on the UK's competitive advantage and also have a large amount of long-term market value. So please download our insight later, of course, and you can read up much more on this, and I've elaborated a lot more on what I've highlighted here today. So now we move on to the present, and building on this initial work and through broad engagement with the industry, we've generated and whittled down to a clear set of directive challenges across 4 themes to focus UK industry investment on high-value opportunities. The technology challenge themes are as per our breakout sessions today. So the first one, Excited to Fly, all about how we bring back enthusiasm to fly and make it a truly desirable experience in its own right, and all the technologies that might enable that. End-to-end sustainability, designing products and developing technology and materials for a sustainable, energy efficient and recyclable and durable cabin. Biosafe is all about covering pre-existing and new issues to restore passenger confidence and build future resilience. Cost weight performance cuts across all the other challenges, focusing on manufacturing and other technologies to deliver exciting, sustainable, biosafe cabins without compromising cost and weight. I'd like to thank all of our brilliant panelists who you'll meet later from across our sector who are supporting this event and our ambition. I'm looking forward to the discussion later. I'll be hosting the Excited to Fly panel. So just flashing up the technology challenges that sit under each breakout theme. Our panelists will be fielding questions from the audience to unpack these challenges and stimulate ideas. The challenges will be presented on an interactive whiteboard, allowing attendees to input virtual post-its. These inputs will then be taken by the ATI and NCC after the event, and we'll have focused workshops to help forge new collaborations that may be funded through our program. Before I dive into the main event, I'd like to bring to your attention some work our colleagues at ADS and DIT are doing. As ATI are working to stimulate R&D investment, ADS and DIT are busy developing ideas to showcase new capability, both virtually and physically. ADS and DIT need early customer feedback to deliver these offerings and develop them. So they're considering a tool to help UK companies affordably showcase capability. This would allow you to place CAD model in a virtual environment for 24/7 exposure to global customers and a direct link to your website and sales team. We may follow up with a physical demo at shows like IAX if and when they are confirmed in the future. I'll be following up with a survey after the event to gauge people's interest. So now I'd like to highlight the fact we're using Slido, so please start asking questions. You can open a new browser, or you can use your phone, a browser on your phone. The code is as there 6420208. Please select the relevant theme. So the themes are as per the breakout sessions, and that's where the questions will be answered. So to finish up my introduction, just highlighting the agenda, again, encouraging people to get on Slido to ask questions. The panel sessions will start at 12 and 1, and the panel hosts will close out at around 2 o'clock to summarize the discussions with within each of the panels, followed by my delivering information on the next steps and the follow-up that I've talked about. Okay, so finally, first we have our brilliant lineup of keynote speakers. So kicking off the keynotes will be Sean Cooper, and I'll introduce the rest as they come up. We have a fantastic lineup of keynotes here today. Thank you very much. And thank you very much for joining.
Good morning all. My name is Sean Cooper. I am Deputy Chief Engineer at the UK's National Composite Centre. I'm very pleased to be presenting this keynote to you this morning, representing the NCC in partnership with the ATI. First, I would like to start with a very short overview of the National Composite Centre. The National Composite Centre is based on the outskirts of Bristol at Emerson's Green. It is a world-leading composites research facility with a global precedent in aerospace composite materials engineering for both structures and interiors. We have some of the world's best engineers and one of the most capable manufacturing research facilities on the international stage. Our purpose is to accelerate R&D for new composites across many sectors, including aerospace, in order to enhance the UK competitiveness in a globally growing market. The NCC was opened in 2011 and since has seen investments of over £200 million in expertise and industrial scale composite manufacturing equipment. We operate in headquarters of over 17,000 square meters with over 300 engineering staff. We have direct access to the leading academic Axis Centre at the University of Bristol, and since our rapid expansion, we now have an additional facility located in Filton, Bristol. We have over 40 active members at the NCC across 8 major industrial sectors. I move now to the main body of the presentation today, the role of composite materials in aerospace interiors. The history of aerospace interiors spans several decades and encompasses a wide range of aircraft platforms. Ever since commercial flights began and through the golden age of travel in the 1950s, the aerospace interior has been used as the face of the airline and designed and manufactured thoughtfully to be at the forefront of the passenger experience. In 1950, the cabin was much different to that of today. All seating was first class, fully reclining, wide seats designed for maximum comfort with ample legroom. But with starting prices for transatlantic travel return journeys priced at equivalent £4,000 in today's money, flying was only for the rich. Air travel today is very different. The introduction of the Boeing 747 for Pan Am in January of 1970 and the gradual increase in flight numbers and annual passenger count through the 80s and 90s has given rise to the dominance of PAX percentage utilizing economy class travel. The passenger need for convenience and comfort at increasingly lower costs has driven massive change for the interiors market across all platforms, including long-haul, short-haul, regional city hopper transports, and private or business aircraft. Higher seat numbers and more weight for passengers and luggage and increasing mass of in-flight entertainment has driven a weight loss regime for interiors similar to that of the structural airframe. The ability to design and manufacture interiors from lightweight materials to offset the increasing operator cost for burning fuels, together without removing the passenger experience, is of higher value today than it has ever been. As a part of this so-called interiors weight loss regime, composite materials began to emerge in regular service throughout the cabin as early as the 1980s. The introduction of Nomex honeycomb, a flame-resistant core material developed by DuPont in 1967, is now combined with glass and carbon-based phenolic prepregs to manufacture low-density but highly stiff sandwich laminates. This composites technology has been dominant for some time and used widely across the cabin, including for seating, flooring, galleys, and stowage. This present day in 2020 provides new challenges but great opportunities to airlines and to the aerospace interiors market, which will be discussed as part of this event. As a cascade, this will also challenge the supply chain for interiors composite materials and manufacturing. Flight shaming and passenger awareness of carbon footprint, combined with legislation such as UK Net Zero Carbon 2050, have given a launch pad for new sustainable materials and manufacturing processes. There is no doubt that the recent COVID pandemic has challenged the aerospace interiors industry, but emerging from it proposes new opportunities for innovation to increase future flight safety. The exponential growth forecast for new personal taxi-style vertical lift platforms could realize a true high-volume opportunity for aircraft interiors. And 3 new Airbus hydrogen-fueled platforms, branded as the Zero E range, for entry into service by 2035, provides a great opportunity for ultra-lightweight and sustainably sourced zero-emission solutions, an area where composites have the potential to dominate. Composite materials can be found across all areas of the cabin currently. First class and business class seating, cabin stowage, ceiling and wall liners, seat backs with IFE integration, flight and cabin crew rest compartments, galleys with catering, storage, trolleys and partitions, flooring tracks and rails, seating plinths, baggage hold panels, the WC and wash basins, and also economy seating structures. Although composites are currently widely used, it is known that within each type of interior structure listed here, that there are still numerous opportunities. May that be for new design practices and new composite materials, driving even further lightweighting, reduced development times and reduced development costs, greater integration of multi-part assemblies, new sustainable options, and perhaps most attractively, there are increasing opportunities for the composite supply chain to adopt new and novel manufacturing practices to help reduce the supplied per part costs and improve profitability. These are all areas in which the NCC is currently supporting the UK supply chain as part of its aerospace interior strategy. The NCC formally started a dedicated aerospace interior strategy in late 2019, in part as a response to the market and technology highlights as introduced by William in the previous presentation, and related to the insight investigations that ATI have conducted. As a part of this NCC strategy, we are currently interfacing with industry bodies and the supply chain at a variety of levels. We are engaged with the ATI and ATEC programs by supporting a number of composite-centric active bids and project proposals for funding. We have engaged with both the ADS Aerospace Interiors Group and with Composites UK in order to understand the new interiors technology shifts and trends, and as a means of showing within those forums where the NCC can add some value to the projects and themes. We also interface directly with business and R&D contacts in the UK supply chain companies and with our members that operate in the aerospace interiors market. This is an ever-evolving strategy, and we are doing more at the NCC now to support UK interiors than we have ever done in the past. We would welcome any new conversations if you feel there is any support or partnership we can offer to you or to your company. The NCC Aerospace Interior Strategy is focused around 4 main themes. Assemblies and structures design. This theme targets composite materials for interiors products such as seating, stowage and galley assembly, joints and fastening technologies, interfacing via brackets and bolted connections, seat legs, seat backs and seat pans. Physical and mechanical performance. New materials including additives and novel solutions for improved composite performance such as fire-resistant polymers, intumescent liners, coatings and veils, fire-retardant fillers, fire-resistant adhesive and assembly techniques, static and dynamic assessment. Materials and manufacturing. Manufacturing best practice and novel technologies for sandwich panel manufacture, automation of composite manufacture, thermoplastic technologies, surface finishing, edge sealing, potted embedded inserts and fasteners, skin to core bonding and lamination techniques. And sustainability, an increasingly prevalent area across all manufacturing sectors, including interiors. The NCC is investigating new sustainable practices for composites, such as bio-based resin systems with FST performance, using biofibers as reinforcement, assessment and understanding of composites product life cycle for understanding CO2 offset, further composites lightweighting from advanced performance, and new materials with REACH, COSH, and health and safety compliance. The NCC has a huge range of manufacturing development cells and equipment. It is one of the most, if not the most, well-equipped composites R&D facility in the world. Shown on the screen are just 3 pieces of equipment that are currently being used for aerospace interiors research. From left to right, we have firstly the 1100 tons PEI press, which is able to process composites via high pressure resin transfer molding, HPRTM, and also able to process both thermoset and thermoplastic sheet and bulk molding compounds. The Engel Duo 1700 ton injection overmolding cell combines the thermoforming of thermoplastic laminate and the injection molding process for the manufacture of net shape hybrid stiffened structures in a sub 2 minute cycle time. And on the right hand side we have the smaller hair press, which operates up to 100 tons for thermoplastic forming, which uses infrared panel heaters and which is also able to process SMC and BMC parts in both thermoset or thermoplastic. We also have a significant composites design and simulation capability, for example using Moldex 3D to predict injection overmolding processing, outputs to optimize the component shape, and using the output simulations to inform or de-risk tooling design and reduce manufacturing costs. We also use Aniform and Pamform softwares to predict the drape of heated composite sheets during the thermoplastic forming process. This predicts the onset of defects including inter and intra-ply shear, ply wrinkles, and fiber breakage. The outputs from the process simulations shown above can all be imported into Abacus for stress simulations and structural FEA, and we are currently developing our approaches to static and dynamic stress simulation specifically for aircraft cabins, as outlined in the following case study project. This case study example is a live project being conducted by the NCC internally with the use of our catapult funding. This project aims to develop NCC expertise and capability for new composite materials techniques for replacing aluminium in the aircraft cabin. We are developing materials assessment practices, simulation and stress models, and manufacturing process innovations, which can then be rolled out to support industry as part of the NCC offering. This project looks at a pair of use case components, which are the lateral and longitudinal stowage brackets on the A320. We have bought a quarter fuselage section from the decommissioned A320, shown in the top left photo, which is currently being used on site at the NCC headquarters as a test bed for the new composite alternatives to the existing aluminium structures. There are significant challenges afoot with this project. We need fire, smoke and toxicity compliance, a high rate manufacturing process with circa 40 to 80 units per aircraft, a weight reduction requirement, static and dynamic loading conditions to satisfy, and a cost neutrality driver aiming for a truly low-cost composite option. We are developing NCC capability right now to deliver on all of these points. So I come to the final slide of my presentation today, composites manufacturing research at the NCC and how to engage. As discussed, we have a wealth of NCC capability to support companies with interior R&D programs. We operate within the total composites product development cycle by supporting from product concept design to material selection, coupon and substructure testing, manufacturing process development, and NDT inspection techniques. The NCC is an open access to all facility, and the NCC can be joined by various membership options designed to be accessible by all business sizes from SME through to OEM. We can also engage through private venture project options, and the NCC can also provide support with bid development for CR&D consortia-based projects, such as for NATEP or for ATI applications. So thank you very much for listening. I've provided on the slide my contact information should you wish to discuss any aspect of the presentation shown, or if you wish to discuss how the NCC may help you with your composites interiors technology developments in the future. Please enjoy the rest of today's UK Cabin Opportunity event, and we look forward to speaking with you again soon. Thank you again, and I'll bring you to the end of my presentation.
Right, thank you very much, Sean at the NCC. So the NCC are partners with us on this event, and they've been instrumental in helping get this event together, bringing it to you. So thank you very much, Sean Cooper and Vicky Summers, who will both be hosting 2 of the breakout sessions later today. So next we have Craig Lawson showcasing some cutting edge research at Cranfield, and also giving us a bit of an update on their current offerings, including their Dartec facility, which is very interesting, particularly for this. Over to you, Craig.
Hello, I'm Craig Lawson from the Centre for Aeronautics at Cranfield University. I'm very pleased to have been given this opportunity by the ATI to tell you about some of the research in airliner cabin systems that we have been undertaking and the exciting facilities that we are currently commissioning. These facilities are going to advance and accelerate research and development in the UK in the fields of passenger experience and cabin technology. First, a little bit about aerospace research at Cranfield. Cranfield is unique in its focus on aerospace and management and its postgraduate only teaching status. We are a research-intensive university operating more closely to industry and to higher technology readiness levels of development than any other UK institution. We stand apart with our own airport that is the heart of our aerospace research capabilities. We host the Met Office facility for airborne atmospheric measurements and run the National Flying Laboratory Centre, where we're currently commissioning a SAB 340B to update our flying testbed capabilities. The Aircraft Integration Research Centre is a £35 million partnership between Cranfield, Airbus and Rolls-Royce. Our latest major facility is Dartec, which is currently being commissioned. The Digital Aviation Research and Technology Centre is a £65 million partnership to greatly advance technologies in the air transport sector. The founding members are shown on this slide. Together, we'll transform the aviation sector by using digital technology to deliver greater efficiency and enhance passenger safety and experience. New partners and associates are welcomed to Dartec. This short video illustrates what the completed Dartec building will have to offer. You can see our Boeing 737 under its new canopy. The aircraft was kindly donated to us at the end of its service life in 2014 by British Airways. Our B737 is already an active research and teaching facility in its current position on our apron. Inside the Dartec building, on the ground floor, there will be areas to discuss business and to socialise. There will also be laboratories to enable low to medium TRL research through technology demonstrators. On the first floor is our mock airport departure gate, which we will use for research in airport passenger experience enhancement. This is an aerial picture of the emerging Dartec building taken last month in September 2020. The construction continues at pace and the keys will be handed over before Christmas this year. This will be a few months later than was originally planned because of COVID-19 related delays. The research priorities of Dartec include the safe integration of UAVs into civil airspace, and we have extensive air traffic management simulation capabilities, as well as the UK's first airport digital control tower. The conscious aircraft is another theme, and this will enhance maintainability as well as passenger experience. Seamless passenger experience is a research track that will be advanced through our emerging passenger experience laboratory. The scope of the seamless passenger experience theme includes the complete end-to-end journey. A holistic approach is taken, including the relationship between the airport and its environment. The importance of transport to and from the airport is recognised, as well as the need to address the desirability of spending time at the airport. Onboard passenger experience improvement is at the core of the theme. The Passenger Experience Laboratory is our main facility to advance the seamless passenger experience research theme. Our B737 is a live laboratory with the opportunity to integrate novel technologies into the cabin. Here we can progress novel designs through the technology readiness levels by collaborative research with industry. Colleagues with expertise in airport and air transport management ensure the relevance and coherence of our facility across the aviation sector. The Passenger Experience Laboratory serves to facilitate the accelerated progression through the TRLs from idea to product. Starting from the typical idea generation stage that you would expect from an academic institution, our capabilities allow these ideas to advance through application. Digital mock-up using virtual and augmented reality facilities are available, as well as rapid prototyping for physical mock-ups in our laboratories. Our B737 Cabin Technologies Integration Facility and expertise in air transport management in partnership can progress novel cabin technologies through to TRL6 and support the transition as they progress to level 7 and beyond within industry. Our new facilities are built upon the foundations of our research track record in cabin technologies. Cranfield is the first university in the UK to perform an in-depth review of passenger cabins in modern times. With our current expertise stemming from two projects, the FUCAM project, where we considered potential technologies to enable disruptive cabin concepts with Airbus, and we investigated market opportunities for the most promising technologies in the UK with the ATI and achieving the difference. We are well positioned to continue this work with new and existing partners. To protect IP, we build internal firewalls when required and are accustomed to working with multiple competitive partners, including continuously and simultaneously with Airbus, Boeing, Rolls-Royce, and Safran, to name a few. The Future Cabins for the Asian Market project was an EU-Japan collaboration involving JAMCO. During the Airbus-led FUCAM project, Cranfield researched a vast number of technologies with a view to cabin applications. Around 4,000 technologies were reviewed and almost 400 captured in a cabin technologies library for potential integration into an enhanced cabin. We worked in both push and pull modes in the sense that we presented technologies to inspire cabin designs, as well as seeking technologies to enable novel cabin functions. The drawing on this slide shows a lower deck application for A350. Our doctoral researcher, Roman Kerenskis, has developed new methods and tools to assess the suitability of technology for passenger cabins. The method allows us to consider the needs specific to a particular market, customer, or even particular route. Our project with ATI and Achieving the Difference looked into the market potential for some of the identified technologies, which has enabled time-bound ranking with regards to market and industry needs within the UK. The technologies have been evaluated in the scope of a robust and comprehensive cabin breakdown structure that was defined during the project. The cabin breakdown structure is different from a product breakdown owned by OEMs, since it looks at generic cabins as a whole and is not linked to any particular OEM's product line. By looking at candidate technologies and evaluating them from the point of view of attractiveness and competitiveness in the UK context, we were able to map the findings. Aligning the resulting candidate technologies from both the ATI and FUCAM projects demonstrates commonality, which indicates good potential for new products that would be equally well anticipated worldwide. The most promising technologies were then used to produce a roadmap. More details of this work can be found in the ATI's Insight number 14 publication on the UK cabin opportunity. I will finish this talk with a few examples of the technologies that could be integrated to achieve an enhanced cabin and to meet the ATI technology challenges. Some of our students have given extensive consideration to the technological means of dealing with pandemics and biological safety, in search of a way to get the world back to flying. One case study has focused on minimized physical contacts in the cabin through the deployment of existing and emerging technologies. Some technologies have been considered with getting the passenger excited to fly in mind, enabling disruptive, unexpected cabin experience that matches the most advanced experiences that the passengers can now have on the ground. This includes solutions to make cabin services and operations smarter. It also enables enhanced systems that the passengers can use personally, including in-flight entertainment and environmental control. Another core aspect that drove the consideration of new technologies was the quality of the cabin itself, the sustainability of its materials, efficiency of the structures, performance of the onboard electronics and communications. These technologies promise the potential for enhanced, sustainable cabins with lightweight materials in the future. Thank you for listening, and I very much look forward to our discussions and future collaborations.
Live.
Thank you very much, Craig. So as you can see, there's some great capability at Cranfield and some great opportunities for collaborative research and progressing technology through their different facilities. So next we have Stephen Elliott from Williams and JPA Design, who have an amazing presentation on their disruptive lightweight seat development, Project AirTech, partly funded through the ATI and also include SWS certification in their collaboration. Over to you, Stephen Elliott.
Firstly, I'd like to thank Will at the ATI for giving us the opportunity to present the AirTech project as part of this UK cabin opportunity. My name's Steve Newbury from Williams Advanced Engineering. I'm going to give you an overview of the AirTech project. AirTech is a collaboration between Williams, JPA Design and SWS certification. We're using this project to showcase how us as specialists can develop a lightweight business class seat structure and disrupt the current state of the art that's available in the market. Cost, weight and performance is absolutely key to this project. And I would also add that passenger experience too has been given a lot of consideration, because we're not just designing a seat structure, but JPA Design have also contributed a fabulous seat concept design, which we've incorporated the seat structure into, so we're able to provide not just a lighter weight seat, but also an enhanced passenger experience. I'm going to give you an overview of how we're using this project to drive forward innovation that would ultimately benefit the UK supply chain, airlines and passengers all around the world. So AirTech is a part ATI funded project. It's kind of in response to the recognition that there's a global urgency to reduce weight and improve the sustainability of airline operations. So we've put together this team and we're really driving forward innovation, pulling in new technologies and thinking about the whole design and passenger experience and cost performance triangle in a holistic way. So before I talk through this in more detail, I'm pleased to invite Elliot Kohler, Creative Director at JPA Design, who's going to give you an overview of the AirTech design principles that were deployed to make this such a desirable product.
Thanks, Steve. Our strategic approach to this design started with the creation of a language that will instantly communicate the benefits of this new seating structure, the monocoque. To name just 3 of those unique benefits: a reduced cost of ownership due to its reliability, a reduced part count, making production efficient and robust, and a drastic increase in passenger space by removing bulky metallic structures. We convey these revolutionary benefits by using a palette of visual design tools, one being a lightweight design language made up of floating surfaces. We have also considered how we can bring a soft simplicity to each edge and an increased sensation of space, such as designing the shell with a slightly outward flute. The most visually striking feature is the fully open monocoque structure, which is open for extra passenger legroom, living space, as well as a full-size cabin bag, something never before seen at this level on a flying business class seat. The front of this storage has a lightweight nylon strap. This combination of lightweight fashion is applied throughout the seat, from a laptop securing strap to a braided coat hook that has no internal cavities to clean. Our textile dress cover is a single piece with a sports-inspired gradient and soft compression molded diamonds. The back surfaces are high in contrast to synergize technology and tuck into shadow critical requirements like electrical boxes and cable routing. The design process of this seating platform is so much more than just how it visually appears. We consider the manufacturing from the start to leverage materials and structures to change the experience for a passenger and ultimately an airline brand. Underneath the seat is a slim pancake kinematic based on the spatial envelope of a currently certified seat. The in-seat storage for the cabin bag eliminates the need for overhead bins, further reducing weight and CO2 emissions, making this the lightest business class seat and cabin ever. We hope you continue to follow our progress as we look forward to our launch in 2021.
Thanks, Elliot. That was fantastic. So moving on to cost, weight and performance. I'm going to explain some of the approaches we've taken to driving down costs, our strategy for weight reduction, how we're approaching meeting the certification and in-service performance requirements, and then moving forwards how we can build leading UK supply chains. So in terms of driving down costs, we've done a number of things which all are working to keep the overall development and piece costs down. So firstly, material selection is key. And then we are designing for a tooling strategy and around the manufacturing volumes that we would expect for this project. So there's optimization around not just the material cost, but also the economics of manufacture. We also see this in terms of increasing the life of an aircraft seat in service. So we've given consideration to the way that the design has incorporated the structure to enable longer life, maybe maintenance longevity and refreshes in use. So this is responding to feedback that we've received from airlines. We're also looking at strategic partnerships for manufacturing exploitation and how we design the structure and the tooling for modularity to enable us to fit this seat onto different aircraft platforms, but still maintain certain economies of scale. So there's a great deal of thought being given to that. One of the core challenges that we've identified is if you look at how certain collaborations in the automotive sector on low to medium volume products, which is what business class air travel is, there's often collaboration around sharing platforms. And then each brand has the ability to rightly tailor the style and to suit the brand guidelines. So we're currently discussing with a number of seat vendors and airlines their appetite for collaboration to ensure that we can maximize the sort of economic benefits for all for this product. The second area is the weight reduction strategy. So this is largely driven by engineering to ensure that we're optimizing our structure design. We're not over-engineering. Obviously, careful material selection is important, and ensuring that we use the right materials for the right load cases, because that's how we can develop efficient structures. Also, our tooling strategy is being determined to ensure good consolidation of materials, because we need to demonstrate to the regulatory authorities that we can maintain good quality in manufacture, and we don't need to over-engineer significantly. So those are some of the approaches. As we move forward with the project, we'll be able to explain in more detail the actual tooling and material selections that we've kind of decided. But just to say that, you know, we're working with expert partners in materials to really drive innovation and push the boundaries of what's possible with this structure. In terms of core challenges that we've identified, we have been looking at short fiber thermoplastics, and engagement with the regulatory bodies is going to be key to enable these kind of new technologies to be allowable for structural applications in aircraft interiors. So the next point, our focus on certification and in-service performance targets. So this has largely been led by SWS certification. Our approach is very much focused on a pyramid approach. So we are gradually working from new materials innovation into coupons and then moving forward into components. That's our approach, whilst correlating the test results with our the extensive CAE analysis that we're doing in-house. So this provides the opportunity for us to really create a rapid product development approach and sort of speed up the adoption of new technologies into our designs. So one of the core challenges that we've identified is where we want to minimize over-engineering. Maybe there's a requirement for some kind of structural state of health monitoring to provide kind of reassurance to regulators that we understand should there be any degradation of the structural performance of composites in use. So then moving forwards to the next slide. In terms of building UK supply chains, this project is really focused on building capability and new IP in the UK. The project is engaged with airlines all around the world and seat vendors all around the world. So it's actually an excellent project to showcase UK capability. So that sort of international reach and partnerships is essential to be able to exploit UK technology at scale internationally. We're also bringing, for example, this is a collaboration between government and industry, but we've also feeding in specialist academic knowledge into this project. And the aim really is that we're going to be able to build super lightweight, future-proof structures that have got, really disruptive IP embedded within them. And then moving forwards, we can see how just looking at the ATI's new Fly Zero program, the technology that we're developing here within AirTech would be extremely relevant to help shape the Fly Zero interior strategy, not just in seat structures, but in other aircraft interior components. And one of the opportunities that Fly Zero may present is actually to rethink about the structural interface points in the airframe and how we can improve the load paths to aircraft interior structures. Because if we can design the aircraft structure and all the weight that's being used in the aircraft interiors together, then we can create much more efficient airlines overall. So that's the end of my presentation. If anybody is interested in what we're doing and would like to find out more, then please contact either myself or Stu Alden at Williams Advanced Engineering, and we'll be happy to introduce you to the team and give you more information. Thank you very much.
Thank you very much, Steve Newbury and Elliot Coller. Now we're over to Jan from ICF, who'll be doing a study into biosafe technologies or viable biosafe technologies working for the ATI. Over to you, Jan.
Good morning, everyone. My name is Jan Cambier. I'm a director at ICF. So in this session, we are going to present some of the initial findings for a study we are doing for ATI on the biosafe threats within the end-to-end air travel system. So a quick introduction about ICF. So ICF is an aviation consultancy, and We are a team of about 80 to 100 consultants specialized in the aviation industry. So we cover projects for airlines, airports, lessors, and aerospace and MRO. So the projects we do range from market analysis to a full business plan to transaction due diligence and operational transformation. So with regards to the study we're currently conducting for ATI, it's a study that aims at mapping the phase of the air travel system where there is the most risk for virus transmission. And then once we've identified at which point in the system there is the most risk of virus transmission, we look at what are the procedures and the technologies available to reduce the risk. We try to identify which ones are the most effective and the most likely to be implemented. And the aim is to conclude what is the opportunity for the UK aerospace supply chain. So as you probably know, there are three main sources of transmission. So there is direct contact. So that can happen at the gate, at security, during the boarding. So when we talk about direct contact, it could be people coughing, sneezing. It could be direct contact in a queue. And the main mechanism for direct transmission is aerosol droplets. So examples of viruses that are subject to direct transmission is COVID, MERS, influenza, and rhinoviruses. Obviously, this is not an exhaustive list. Then we have indirect contact. So that can be when you touch contaminated surfaces. So clearly, an example is when you go to the laboratories. So example of viruses transmitted through indirect contact are noroviruses and enteroviruses. And finally, the third main source of transmission is via vectors. So that can be through mosquitoes, flies, ticks. And example of these viruses are Zika, dengue, and chikungunya. So according to virologists, there is what they call a P6 strategy that is suitable to limit the risk of transmission and limit the risk of epidemics through the air travel system. So first is a proactive and preventive action. So clearly, prevention is better than the cure. Then there is physical protection. So for example, when social distancing is not possible, for example, when you're sitting or when you're boarding, having a mask or PPE is a way to reduce the risk. Passenger health. So here it's very much talking about making sure that passengers are aware of the risk and that they travel only when they are in a fit condition. The fourth one is perception. So clearly, it is key for the flying public to feel safe. And so implementing tangible solutions that are visible, that have an impact, and that are simple to implement will be key to make passenger comfortable. Then pace. So here it's leveraging the knowledge learned from other industries and applying it to the aerospace industry or the aviation industry. And finally, package. So here it's to basically say that it is key to ensure that the solutions identified and implemented are done alongside an effective communication campaign to ensure that the passengers knows what to do and feel safe about what is being implemented. So in terms of the more technical aspect of the study, so we mapped the journey for the air crew, the ground crew, and the passengers. So clearly, if you look at this map, you will see that the passenger is more exposed to potential virus transmission than the crew. So passenger is exposed predominantly, but not solely, like during the boarding at the gate. So everyone has been boarding a plane where like you all scan your boarding pass, your passport get verified, and then you're queuing in the tunnel. And this is still happening nowadays, despite the social distancing measures that are advertised everywhere. There's the risk of direct transmission also when you're, for example, transported in a bus from the boarding gate to the plane. And clearly, like during the flight, there are risk of transmission, both direct and indirect risk. So if we focus on the passenger, like while on board, so you can see that there are different situations in which the passenger can is during the flight, and like some of them present more risk than others. So during the flight, like the passenger will board, will position its luggage in the overhead bins. It will go to the toilet. It will order food and beverage. It will collect its luggage at the end of the flight, and it will disembark. So, for example, like the collection of the bags at the end of the flight is clearly a risk area. That's more because of the queuing, so risk of direct transmission. Like everyone has been on a flight where all passengers are trying to get up as soon as possible to collect their bags and disembark as fast as possible. So that's a risk that can be mitigated more via procedures. And then, like for example, the use of lavatories like present a number of risks for indirect transmission. And clearly, the industry is looking at solutions to limit this risk. So the market interviews we've conducted reveal a number of things. So airlines favor simple solutions. So clearly airlines are cash constraints. They don't want to have to spend too much money on technologies or solutions that to reduce the risk of transmission. So they favor like the most simple, most effective solutions they can find. And again, like the idea of having to reconfigure a cabin is something that's quite expensive, and something that in the interview we've conducted is not favored at this point in time if it can be avoided. The second theme is that a cabin filtration system is recognized as safe, and I think it's a standard view across the industry. Queues are the main threats, and airlines don't all have the same standards with regards to queue management. So interviewees believe that full service carriers are putting more procedures in place to limit the risk of direct transmission during queues than low-cost carriers. And finally, like as always, like any solution needs to be certified, and that's a hurdle to overcome, and that could take time. And the certification was mentioned in particular for like seat headrest dividers. In terms of like assessing the solution, so this is still work in progress, but we try to assess solutions being talked within the industry, either existing solution or solutions in development through their likelihood of reduced risk of transmission, their economic feasibility, so how expensive they are and how likely airlines are to implement these solutions if made available to them. The engineering viability, so how likely are these solutions to be available in the short term, and finally, like the impact on passenger confidence. So will this solution like make the passenger more confident that it is safe to travel with that specific airline? So to conclude, like again, this is not the exhaustive list. It's only some high level, but from a procedure standpoint, like clearly there is nothing new, like social distancing, wearing PPE kits and facial masks, and maximizing the implementation of antigen testing and track and trace are the procedures that are going to be the most effective in any situation of an epidemic and limit the risk of transmission. When we talk about technology, like it was noted that whilst the HEPA filters are of high standard and the cabin air filtration system is safe, like there are suppliers looking at systems such as air blades and air shields to direct the airflow within the cabin and further reduce the risk of transmission through air droplets. So, for example, like if there is a passenger who already has for example, COVID, if we talk about what happens nowadays, like before the air gets filtered, like how do you direct the air to minimize the risk of transmission? Then touchless lavatories, so clearly like the less passengers have to interact with the lavatories and the environment, like the less risk there is with indirect transmission. UV cleaning and sanitization, so again, like a number of airlines have implemented this, but like there are clear differences between some airlines practices when it comes to how they clean their cabin and what they use to do the cabin cleaning. And then from more of an airport standpoint, like there are talks of smart restrooms, so how to ensure that that toilets and restrooms are getting clean based on usage. So ensure that if at a specific gate there is a toilet that is being used more than at another gate, this is the restroom that's getting cleaned the first and the fastest. And finally, crowd management. So again, in order to limit queues, like what technologies can be implemented to monitor passenger flows within the airport and making sure that there is no crowding at any point within the airport. So that's it for this very high level presentation of our findings. And I believe as we complete the study, like ATI will share with you more details of what we found for this study. Thank you.
Thank you very much, Jan, from ICF. So keep your eyes peeled for that presentation, for that work when it comes out. We've also been working closely with DFT and CPNI. So and they'll be following up after this if you'd like to have a deeper dive on that topic when we've concluded. I'd also like to point out Slido. Keep your questions coming through the Slido web browser with the code 64208. It's also on the meeting invite, and choose the correct panel to direct your question. So now over to Pliable. So a brilliant startup who are on our first cohort of the ATI Boeing Accelerator and supply composite tooling solutions with very smart technology that obliterates lead times for composite tools. So over to you, Martin.
Hello, everyone. First of all, thanks to the ATI and also to the NCC for putting on this event, both of whom are great supporters of the composites industry, but also Pliable. So thank you for the invitation to speak today. With this being a virtual event rather than in person, I've decided to shift the team slide to the front in order to give some human context and background to the team that have built Pliable over the past 2 years. My name is Martin Orton. I'm the CEO and co-founder at Pliable. And like lots of good ideas, Pliable started in a pub. It started as an idea between 3 friends, an idea to make composites manufacturing easier. We wanted it to be as easy as making something from metal, more of a commodity and less of a dark art. My background is in composites engineering. I had a small design consultancy business for about 7 years before starting Pliable. In that, I worked across many sectors, including commercial aerospace, but my passion was for yachts, and we worked on several America's Cup projects, designing high-performance composite structures for yachts. We have 2 other founders, both called Adam, which makes it much easier to remember. Adam Lofts is our CTO. After graduating, he co-founded another technology startup that worked with enterprise customers like PepsiCo and RB to track and report their carbon footprint using a digital platform. Lastly, Adam England. Adam really has been at the coalface of composites for the last decade. He worked his way up from the shop floor and has experienced all the challenges in the majority of departments. So that first meeting in a pub in Oxford was over 2 years ago, and it's now no longer just an idea. We have a fantastic team of 10 people supporting our product development, our order fulfillment, and sales activities, looking after our customers on 4 continents. Pliable is a digital manufacturing platform. In this regard, we are not unique. Like other platforms, we have reached out to landlocked small manufacturers and have been able to use their stranded capacity, which not only gives a return to the owners, but it smooths out the markets that they operate in. This shift to manufacturing as a service has become possible as a result of technological advances, such as faster internet, cheaper cloud resources, and increased connectivity. These developments are enabling a fundamental transformation of the global supply chain. And at Pliable, we are specifically focused on the challenges around manufacturing with composite materials, particularly the requirements right at the start of a product life. I was listening to another webinar recently, and one of the speakers noted that tooling is often one of the first things on the critical path and one of the last items to get finalized. In my earlier career as a composites engineer, we noticed that this was actually hindering development and also the wider adoption of composite solutions. Currently, tooling accounts for over 50% of the cost of bringing a product to market, creating barriers for anyone with a new idea. Aerospace companies produce astounding innovations every day, and this can offer the illusion of next generation manufacturing, but the truth is far different. So many other industries before us have enjoyed their tech moment. Fashion, finance, and travel, to name a few. Now is the time for manufacturing. We have created a frictionless B2B e-commerce platform, and our advanced software enables instant quotes for tooling in a wide variety of materials, direct from component data. We use computer vision and AI to automatically design tooling solutions for molded components. And more features are being added all the time, leveraging the ability to utilize compute power in the cloud. Hopefully you can see we are not your average tooling supplier. In fact, we are really a technology business. However, that's not what I'm going to talk about. Adam Lofts, our CTO, gave an excellent presentation recently on our technology and how we use AI. His presentation is still available online. There's links to it on LinkedIn and all our social channels. Please check it out. And if you can't find it, let me know and we can send it to you. The focus today is on the benefits that this can bring to all the different stakeholders. Now, this slide here is meant to represent a cross-section of the different departments and people that were involved in any one project. And information needs to flow between all of these smoothly and with transparency and traceability to ensure quality. The truth is that although we have talked about Industry 4.0 for many years, the majority of teams still rely on technology that was invented in the 70s. It's now October 2020. And therefore, as well as how we are changing manufacturing, we will, of course, also mention COVID, because how can we not? Rather than dwell on the negatives, I'd like to show how we can use this disruption as an opportunity and as a catalyst going forward. I want to quickly talk about supply chains because we are all reliant on these. On these next few slides, it's a lot of stats and facts. I won't dwell on these. It's not the main topic for today, but some are quite enlightening. This is a 2x2 matrix on impact and predictability of events. It's no longer surprising to see pandemics in the top right. We are all well aware of the disruption caused by C-19, but it's actually managed to shine a spotlight on some elements that in the past often operated in the shadows. The amazing key workers being obvious, but also the global supply chains that play such a critical role in the smooth running of the global economy. Unexpected factory closures interrupted crucial supply links, causing shortages and delays in delivery. While in the past, many companies focused on optimizing their supply chain for efficiency, these have been shown to be weak in dealing with unforecast events. Supply chain volatility is not new, but it is occurring more frequently, and it's affecting a range of industries and regions due to an increasing array of threats. In parallel, supply chains have become more complex and brittle as a result of globalization. It's no surprise to see China at the top of this table, but the magnitude by which it leads, I think, is. When so much is so reliant on one or two nations, how can we possibly build resilience? One thing is certain, globalization has happened, and this is not the end of globalization, but I think we will see a bit of a reset in how we think about optimizing our future supply chains. At Pliable, we expect we will see a shift of that focus to more resilient supply chains, capable of faster adjustments and pivots. 3D printing platform, 3D Hubs, recently produced these results from a survey of over 1,000 customers. I had to include it today because we are striving to achieve all of these. And by us doing it, it also means our customers are also able to achieve this. I touched on how we achieve these more later on, but the key points are diversity in the supply chain, automating previously human-centric processes using digital technologies, and increasing transparency. If something is going wrong upstream, then you need to know about it because ultimately it's heading your way. Now, how do we tie all that in with our technology? And going back to the previous slide, our customers. How is what we are building going to impact and benefit these stakeholders? Today, I wanted to highlight how some of our customers are embracing this right from top to bottom and extracting real value from it. This will ultimately allow them to deliver better products, faster and more affordably than their competitors. I think being engineers, we originally felt like we were building an engineering tool, and it's true that most of our customer acquisitions generally begin by speaking with technical teams. However, going forward, one of the most prevalent use cases we see is with sales and bid teams. Every composite component requires a mold or tool, and it's always a significant line item in any big bid package. The traditional process usually will involve engineering and procurement teams to determine a specification and then put that out for RFI in order to include in a bid document. This can take days, if not weeks. And also significant internal resource in already stretched teams. We realized that a mold solution is a mathematical function of the part being made, and our software enables instant quotes direct from component CAD data. We have quoted on millions of parts, and our algorithm is continuously being fed and learning and improving. This head start, not only in the technology to be able to achieve this, but the network effects of having this large data set gives us a significant advantage and product defensibility. From an engineer's perspective, when you're in the prototyping and ideation stages, time is everything. It's the way you stay ahead of the curve and beat your competition. It's the deciding factor for whether or not your product makes it to production. So even a 1 or 2 day loss matters significantly. Our automated, smarter design tools and processes enable more people to invent. And as a result, Composites innovation is radically accelerated. We have delivered tools in as little as 24 hours. We are now able to offer DFN feedback using our proprietary simulation tools, combined with the power of in-cloud computation, and are working towards automated target-based design, whereby from the CAD file and the process parameters, we can automatically design a mold tool and take into account shrink back, resin flow, and accurate thermal expansion and contraction, all online. We enable engineering teams to use self-service tools, have real-time access to information, and crucially, a single digital thread of information from design right through to production stage. And in an environment of remote team working, Digital platforms have kept workforces connected and productive. Online communication tools like Zoom and Slack, these digital platforms have enabled teams to stay in touch and run efficiently with little downtime. To emphasize the point, McKinsey recently stated that we have vaulted 5 years forward in consumer and business digital adoption in a matter of around 8 weeks. A recent survey showed that B2B digital procurement had soared from 29% to 37% during the pandemic and was expected to grow further in the near future. We enable purchasing teams to maximize their efficiency on their specialist tasks, not chasing. Procurement teams who use Pliable benefit from a fast, digital-first user experience, better communication, and a true market-driven price. We expect that this pandemic will fast-forward the adoption of new technologies and processes, even in the traditionally slow-moving manufacturing sector. We have already seen some evidence that this has highlighted pain points that solutions like ours can solve. As well as the marketplace, our technology delivers efficiencies and enables previously human-centric processes to be automated and delivered online, which will now be more relevant than ever. We always backed the shift to a more e-commerce model for B2B. We felt it was inevitable. That process just got fast-forwarded, and the same will be true for others as well, with accelerated acceptance of novel solutions. The traditional supply chain model, where a handful of countries produce more than 50% of manufacturing output, is over. It's just not resilient enough to cope with the modern world. The future is distributed manufacturing enabled by advanced digital technologies. Our goal is to increase the proliferation of composites. We envision democratized access, enabled by Industry 4.0, and with that a much broader market, including applications that we are only beginning to conceive. We recently worked with GKN Aerospace and were shown to be 44% faster and 20% cheaper than incumbent suppliers. Even pre-COVID, we knew that was a compelling story. In the current climate, it's one that cannot be ignored. Pliable is online right now. It's completely free to use. We are a technology business, but we don't sell software. We deliver hardware. Please always remember that it is run and operated by real humans who are always here to help. Thank you very much for your time today, and please don't hesitate to get in touch. Thank you.
Thank you very much, Martin. Really great, really interesting presentation, that. Appreciate it. Now over to Russ Bradley from AVIC Cabin Systems to give an overview of ACS and opportunities for UK suppliers.
Hello everybody, my name is Russ Bradley. I am the Group Procurement Director for AVIC Cabin Systems. It is my great pleasure to join this ATI and NCC sponsored cabin opportunity event and to provide you with a short overview of our company, our ambitions and our capabilities. AVIC Cabin Systems Limited, or ACS for short, was formally established and launched in 2018 and brings together the skills and capabilities of 5 separate specialist aerospace companies into an integrated whole. We are a subsidiary of the Chinese aerospace giant AVIC, the Aviation Industry Corporation of China, with our company registration being held in Hong Kong and our operational headquarters in London. We are able to offer complete nose-to-tail and floor-to-floor aircraft cabin solutions for passenger aircraft of all sizes. Our customers are airframe OEMs, where we offer SFE or line fit options, and airlines, where we offer both BFE and retrofit options, as well as a full product, spares, and customer support service. In the next few slides, I'll talk a bit more about the famous brands that make up AVIC Cabin Systems, and I'll describe something of our product portfolio. I'm sure many of the company names and brands represented on this next chart will be familiar to you, and many of you may be customers of or suppliers to one or more of these businesses. Each brand brings something very unique to the ACS offering, and in combination, these capabilities are especially powerful, allowing us to combine some or all of them in order to produce a fully integrated cabin design and build. For example, a total solution could include hat rack boxes, ceiling, floor and sidewall panels from FACC and or Fescher, depending upon the customer's location, first class and business class seats from Thomson Aero Seating, economy and premium economy seats from Jatai, and monuments, storage and galleys from AIM Altitude. All of the above can be engineered and supplied with fully integrated services such as lighting, ventilation, oxygen, and in-flight entertainment. AVIC Cabin Systems boasts a worldwide footprint. We have corporate offices in London and Beijing, with our primary manufacturing sites being located in China, Austria, and the United Kingdom. We have a full design team based in New Zealand and have sales and support offices across the Americas, the Middle East, and the subcontinent. As such, we are able to support our customers and our program commitments around the clock. This next slide gives you an insight into work we've been doing over recent months to define the vision, mission, and values of our integrated business. The statements here represent the commitment of all of our people across the multiple cultures and environments in which we operate, and they underpin what is a powerful focus on ACS as a single integrated business, working together, living our values, and speaking with one voice. I've already touched on some of the product types that we can collectively offer as part of our cabin interiors proposition. And you can see on this slide some examples of the multiple seating solutions available, from economy seats through flatbed seating types to mini cabins, as well as examples of interior panels, stowages, galleys, and for those lucky enough to get the opportunity, in-flight bar areas. This slide does, however, also bring into focus another major aspect of our product portfolio, which is the area of lightweight, non-metallic structural items. In the airframe context, this includes elements such as wingtip fences, wingtips, flight control surfaces, fairings, and one-piece structural components, including wing ribs and even complete bonded wing box sections. In the engine and nacelle arena, we produce a wide range of items from cowl doors and acoustic linings to bypass ducts, blocker doors, and translating sleeves. Highly engineered products designed to withstand aerodynamic forces and huge temperature gradients, whilst delivering safe operation, low weight, low noise, high efficiency, and reliable life cycle performance. It certainly seems that our customers across the industry appreciate what we do. We are very proud to be able to post this next slide as indicative of the wide range of aerospace OEMs and airline operators who have adopted all aspects of AVIC Cabin Systems products and technologies. Some of the biggest names in global aviation are represented on this chart, and as you would be entitled to expect as a passenger on their services, they have very demanding standards. Standards which we and our partners and suppliers are determined to meet and uphold. What does all that mean for our suppliers and our prospective suppliers? It means we need the best ideas, the best technologies, the most competitive cost options, and the best and deepest collaborations. It's probably fair to say that this has always been the case at some level, but in the environment in which we now find ourselves, it is at the forefront of every make versus buy evaluation, every supply chain design review, and every sourcing decision we make. The plain fact of the matter is that the outlook for our industry remains extremely challenging and is likely to stay that way for an extended period. The strongest of our customers will, however, find a way through, and they will do that by allocating their capital and their cash with great care. That means that cabin opportunities will arise, and that those best placed to secure these will be those with the best, lightest, highest performing, and most cost-effective solutions. We intend that to be us, and by extension, the suppliers that bring those same characteristics to support us. Our expectations of our suppliers are high, as are our standards for ethics and behaviours at our suppliers. You'll find a downloadable copy of our Supplier Code of Conduct on the Suppliers tab in our website at www.aviccabinsystems.com. If you'd like to be part of the Avic Cabin Systems journey and think you have a proposition to meet our needs, please use the website to register your company. For the record, all new supplier registrations come directly to me for initial assessment. I'd like to say thanks very much to ATI and the NCC for hosting us and this event today. Thank you all for listening to me give this short overview of ACS. And finally, can I wish you all a hugely productive rest of the day. Thank you.
Thank you very much, Russ. Great talk and great to hear about Avic Cabin Systems. And now over to Martin Derbyshire from Tangerine, who'll be talking about designing for innovation, for brand, and with new forms of collaboration. We'll go live to Martin now.
Thanks very much, Will. It's very kind of you to introduce me, and thank you also to ATI and NCC for inviting me to speak today for the UK Cabin Opportunity. I'm excited to be with you. Okay, well, I'm going to talk today about the designer's role in cabin interior design and show some examples of different design work, ideally looking to represent the design industry in total, not just Tangerine. And I'm also going to talk about new kinds of cooperation, initially speaking about barriers and then leading on to discuss some potential opportunities. You can move on, please. So designers bring a wealth of experience in terms of designing cabin interiors, but of course they work in very different markets, not just within cabin interiors themselves. Experience spanning from across multiple sectors. Therefore, they bring an understanding of people, customers, how people think, how they react to experiences, through to brands and how they express themselves in the market and become differentiated, and right the way through to the technicality of how you deliver something and ensure that thing is a better experience than others who are competitors. If you can move on, please. Some examples of this: designers want to raise the bar and deliver the most powerful, the most substantial experiences. So in this case, in this example, showing BA Club World, the world's first flat bed in business class, we were able to create a patent around this format, which protected the space efficiency occupied by the design, but also protected the unique value it gives by putting passengers into their own private space. So on the one hand, protecting the business through delivering density. On the other hand, improving the passenger experience and ensuring that a good experience is delivered. You can move on, please. At the other extreme, a designer's job is to represent the brand, is to deal with the elements of perception which change your sense of the quality of an experience, the sense of the brand that you're going to engage with. And that links through from both the design of delivery, as you're seeing here. If you could move on one, please, as well. Right the way through to all of what we call are the touch points. So every single element that a passenger would interact with, which reinforces their perception of the brand and reinforces the quality of the experience that they are receiving. You can move on one, please. That then, of course, being industrial designers, then translates down into the details of the seating and the cabin elements. And how do we work to look to improve those elements as much as possible, given the timing of a project and the available resources, which of course then means, if you can move on, one more please, Then thinking very carefully about what the original concept design is like. In this shot, you can see the picture in the top right corner of the original seat that we were working to customize, and on the bottom right corner, the seat that was customized and delivered. Part of our work is always to think through how you improve comfort, how you bring change which offers a meaningful benefit for both the passenger and the airline, and ensure that the project can be delivered in a timely way. You can meet the requirements of the airline, you can meet the requirements of the manufacturer, and you can ensure that a good result is delivered for all parties. Designers have a central role in managing all of those activities. You can move on, please. Designers are also involved not just in thinking about the physicality of things, but also thinking about how you introduce features which enable interaction between the crew and the passenger, because the passenger's experience is not just the physical parts of the cabin. It relates to the emotive qualities that they have, and certainly their individual journey and the differences that these bring. You can move on, please. Therefore, designers on the one hand are thinking about people and how do we arrange things so that we make things to be easy to use, to be intuitive, to be comfortable. And at the same time, we have to think about how do we utilize the space on board that aeroplane to the highest possible degree, because clearly space is a dramatic effect, not just weight and cost. And in this case, in the example that's being shown here, we were cleverly able to utilize areas of the front of the cabin in the business class cabin to create seating and space that becomes part of the bar area on board the aircraft. And if you remember back to the slide before, I won't go backwards, we were able to create the perception of a very wide bar, but still utilizing the minimum footprint on board the cabin and provide a balance between customer service and also storing the items that are required to be presented to the passengers. You can move one more forward, please. The most challenging part, and I think a big opportunity which will be spoken about later, though, is how do we bring change through either services or digital integration into the cabin. In this case, and in the example being shown here, we were lucky enough to be able to experiment with the full functionality and usability of a future concept for IFE on an economy seat, thinking not just about content and how content is being provided to a passenger, but also thinking to what potential new revenue streams may be when you have ground to air services working properly. And through having built full-size working systems way ahead of things going to production, we're able to really learn about and understand how customers interact with these new systems, and through using tracking techniques, learn about their real behavior, what they actually do using things, and from that try and understand what the next generation of technology may be that will provide the digital service or the service on board that customers want to have, and that ideally airlines would like to be able to tailor to suit the needs of different passengers or to help their crew deliver a better service. Can you move on, please? So a designer has a central role, we believe, in the part of delivering cabin interiors projects. We value very much our connections to partners because they enable us to become familiar with new techniques and new technologies and introduce those into design work that is being completed very early in a long-term program. And of course, we can also champion those supply chain partners throughout a project to try and ensure that changes we want to make become integrated within a future design. At the same time, we are, of course, thinking about the passenger. We are dealing with the OEM who may be delivering the aircraft, and we are working together with a multitude of suppliers to ensure that the whole experience on board the aircraft is integrated and connected. If you can move on one, please. Designers are also involved in dealing with very different levels of change. We're just showing 3 here, from the very low level where often we're involved in changing colour, material and finish, not involving substantial changes to the hardware. And then that can lead on through moderate levels of change where you're customizing existing seating or existing galleys that may exist, or onto questioning, what could a new customer experience really be like? These sorts of projects are rare though, but I will show one example quickly. If you can move on, please. And I guess something to say before showing that example is that designers will also be looking for quick wins, levels of innovation that can be implemented quickly and easily and bring a moderate level of change. And also thinking ahead about what are the values, what are the features that we can create in the long term, which will deliver a really innovative concept for the passenger and also protect what's being provided to the end customer. If you can move on. So in terms of bringing substantial levels of change, we have to, for challenging projects, we have to think and set a vision for that project. We have to uncover the things that make that be unique and relevant and appropriate. In the case of the Club World seat that I spoke about earlier, the world's first flat bed in business class, and that I think Ben, who will speak later, was company involved in the creation of. The key feature of this design that was important was forming 2 seats together in a rearwards and forwards facing combination, which then gave real space efficiency in the way in which you lay out those beds, but also for the first time introducing a private space for the business class traveller. This sketch was drawn in 1998, so I am taking you some time back into the past. If you can move on one, please. Critical factors in terms of the development of these concepts can be the integration of 3D CAD and utilizing 3D CAD as a means of accelerating the way in which a design is developed. But I think also at the same time, a very important factor that designers bring is that we look to adjacent sectors to try and understand and define what the fundamental things are that will really bring meaningful change. So in the case of this seating concept, whilst the fundamental thing on one hand was creating a lie flat bed in an efficient space, other elements that we introduced were looking at adjacent sectors in the way comfort is being delivered to try and create a breakthrough in this industry sector. If you can move on one, please. So in this case, for the first generation of the Club World seat, we introduced a reclined and very low seating position from the moment a passenger boards an aircraft. So they're comfortable from the minute that they sit down. They don't feel bolt upright. They're relaxed and they can use their space. And we also introduced for the first time using a separate footstool as a means to support their legs. So this then allows them to change posture easily, move around, be more comfortable by introducing a totally new approach. Prior to that, principally leg rests were being used to deliver comfort, and they in some ways restrict comfort because they lock you into one posture rather than enabling you to move around. Okay, you can move on one, please. So in the end, of course, what you're seeing here now is this concept is quite old, but it has transformed the success of the business. The yin-yang format, which started with this concept and led on to the second generation, has protected the fortunes of British Airways. The patent has secured high density in the cabin. And certainly for the last 20 years, this single idea has enabled British Airways to really pioneer forwards and be commercially successful using this sort of concept. If you can move on, please. So in terms of new kinds of cooperation, let me just initially talk about some barriers that we're seeing from a design perspective that I think we have to reflect on how we overcome them in many ways. If you can move on, the first one that we are all encountering is the increased challenges of passing certification. The core of certification critically is to deliver safety, but at the same time, the seat I've just showed to you for British Airways went from a sketch to the first seat flying in 16 months. So, that is barely, less than the time we now have to introduce really minor changes to an existing catalogue seat. And I guess we have to be asking questions around, are there ways to improve that? Are there ways to challenge that? If you can move on. The other challenge that we're experiencing is that, there is a massive focus on delivery and timescales, which of course are really critical. Everybody is signing up to complex, expensive projects and they want those delivered on time. But at the same time, we would have once had an ICCM where we introduced partners and got to understand the beginnings of a concept and then looked to work and develop on that concept. Whereas now we are in a position where we have to present a fairly complete concept that's relatively defined for what essentially is the first program meeting, which is putting huge pressure on timescales to create what those new breakthrough ideas might be that will bring real change. If we can move on one, please. So I think part of an influence on this will be the introduction of new entrants into the market. So this is work we completed with LG some years ago about showing their vision for how flexible OLED technology may enter into the aircraft interiors market. And they, of course, have established a joint venture with Lufthansa Technik and are looking to bring both this technology and new platforms that could introduce new levels of change through AirQ into the market. I hope that we will see others looking to try and achieve similar things, because the change the service and change the digital experience is crucial to bringing change for the customer. And if we can move on one, please. And we are also working, and I'm sure other designers are also working on new concepts that will enable you to track customer behavior, learn about what customers are doing, and enable the systems that exist on board the aircraft to then try and deliver a more personalized service. So this may mean that cabin crew have a better understanding of what the passengers are doing on board the plane, or there may be higher levels of integration and communication between the passenger and the crew, or there'll be greater tracking of what the customer is doing so that the airline can respond in a more appropriate way to their particular needs. So if you can move to the last slide. And then from ourselves, in terms of our approach to the future, we have seen tremendous limitations around change in the economy seat market, where almost all economy seats have become a commodity in many ways. And we will be working under an ATI NATIP funded scheme with a series of partners, including C-Sense, a composites manufacturer, together with Sabeti Wayne, a dress covers manufacturer, and with Collins as our end user, to look to develop a new lightweight comfort system for economy seats, which will try and genuinely improve comfort and still within a tight seat pitch and bring new technologies to market.
Okay. Thank you very much, Martin. Really great talk. Brought up some really important points there, and also demonstrate what can be done with some ATI funding at the end there. Thank you very much. So before we move on to Colin Mahoney from Collins Aerospace, we're going to take a very short technical break. We'll be back within the next minute or so. So don't go anywhere. We'll see you very shortly. Hi everyone, we're back. Everything should be fixed now. Looking forward to the talk from Colin Mahoney from Collins Aerospace. I talk about Colin's vision for redefining air travel. So we'll go live to Colin now.
Well, thank you, Will. And yeah, some of you might be thinking, well, that's a pretty bold title for an aerospace company to put on a slide. But yeah, if you think about the environment we're in, we really have to do something different. And I'm going to spend just a little time on a few slides to give our perspective from an industry lens on why we believe that the future of air travel really needs to be redefined as we move forward here. Why talk to the UK aerospace community? absolutely an incubator for new technology. We've proven it. We've been operating in the UK as Collins for over 100 years now, and you can see the numbers of people and most importantly, the numbers of engineers that we have working on advanced technology for aerospace in the UK. So as we think about redefinition of air travel, collaborating with partners in the UK is an obvious choice for a company like ours. And just quickly, here's some of the advanced technologies that we've been able to produce through that collaboration. Things like our information management systems, the former ARINC company. We're doing robust GNSS here, global navigation systems for military applications. We developed an F-35 simulator here in the UK. Going down to the bottom row, you can see targeting systems. So that's JTAC systems for the UK and many other countries beside. That's Joint Terminal Air Controller. That's the secret sauce of putting a missile on a pinpointed target and calling for fires. And then in the interiors business, we developed and produced the Q Suite for Qatar here in Northern Ireland. And so, that as a Starfax #1 airline is a proud moment for us and obviously UK industry. I want to spend the predominance of my time talking about why we have a unique moment in history for all of us as aerospace companies and executives in creating what we would call the new normal. That's often overused term, but if you contemplate what we've experienced since February this year, and I think starting to nudge 40 million cases of COVID-19 and over 1 million unfortunately lost to the pandemic, on the back of several other much smaller experiences we had with H1N1, SARS, MERS, Ebola. I mean, you name them all. But this one has created a heightened and I think sustained focus on health and well-being while operating with the air transportation system. So we've got to ensure as an industry that the cabin of an airplane is not a vector to continue that. We've got to focus as an industry on what we would describe as layered countermeasures. So think about from arrival at an airport to exiting in your country of destination or location of destination, and how each step of the journey has to be a countermeasure to advance in a pandemic, and constantly reassure those involved in the ecosystem that that is the case. And then ultimately make sure that we've got affordable solutions that support operator fundamentals. That really is an important thing that often we lose sight of, particularly in this time. A commercial airline is in a very challenging financial environment. I don't have to explain that. And they will be in a consumption choice environment where they have to make very tough decisions on how they apply their very precious capital. So we've got to bring solutions that are affordable, that don't violate the fundamentals of operating an airline. So as an industry, so that's all of us on this call, we need to find a way to aid that industry to restore passenger confidence. Because you think about, and for us and many others that have spoken before me, if you look at air transport traffic, particularly international, which is largely served by wide-body airplanes, which are much more meaningful financial drivers in the industry, that last time I checked was down 88% relative to 2019. So we as an industry have to set an objective for ourselves to go find a way to solve for that. And as I say, make it a holistic system approach to solving for passenger confidence. And that's from the airport journey, including the airplane. Speed's going to be key. Agility, cost effectivity, and that comes from finance, that comes from talent. So, we're doing our bit as a supplier, and thankfully now as part of the Raytheon Technologies family, we have a nice balance in the business, with our defense side to enable continued investment in these advanced technologies. But partnering for speed, partnering for finance will help us get to a rapid deployment of those capabilities. And focus on the realities of operating in this new normal. And what do I mean by that? You know, we've seen a flood of innovation. I use that term because a lot of those innovations were ideas that people were quickly coming out with to do things like induced passenger separation, but that would violate the fundamentals of operating an airline profitably. And we did a lot of that early thinking, where we can have a seat blocker in the middle seat on economy class main cabin seating. Not practical long term, very unlikely to be a spend item in the short term, and we haven't seen much or any of physical seat blocking in a main cabin of an airplane. And then make sure that we're focused as an industry on appropriate standards development. And you know, we're highly regulated, we know that, that's for good reasons. But as we think about this new normal and think about some of these new capabilities, how do we collaborate to make an appropriate standards environment? So let me try and bring that together in one slide for you. And this is my last slide, but just to clear it, the top row would be what we would describe as the ecosystem of air travel. In the middle is 3 areas that are notable focus areas for us, and then along the bottom there, what we would describe as foundational enablers to make sure what we're spending our precious time and money on as an industry is actually applicable and executable in the real world. So clearly, ecosystem and how do we permanently change that ecosystem is from arriving in your car at an airport or a taxi, entering into an airport environment, right through to departing your destination airport and everything in between. It's not all about the airplane. It's not all about the interior of an aircraft. And you see the big OEMs in recent times speaking loudly about how safe that environment is, and we're all aircraft people, so we know there's substance to those claims. And you know, there's lots of statistics now. You're even more likely to get struck by lightning than you are to catch COVID on a commercial aircraft. And there's a lot of misunderstanding around that. But we have to focus on that complete ecosystem. So when I talk about that, I'm talking about the airport, the cabin of the airplane, and then the management of air within that airplane. So if you think about airports, and you've seen this, we've all traveled. We all wish we were traveling more, but we're interacting with an airport in a touchless way today. So most passengers are checking in online. You have your boarding pass on your famous personal device, and you're able to very quickly get through a security check-in that way. Self bag drops. So we need to advance that. You can check your own bag in, but now we need to make that experience a touchless one. As you think about biometric screening, we're seeing that start to emerge as we transition through security, through immigration, if you're traveling internationally. So it enables you, again, to not have to interact physically with the systems that have done that historically. And traffic management within an airport, that's something we haven't seen yet, but very doable if we have more of an interaction with the passenger, more of a control of flow through an airport, so that we can monitor crowds, monitor overcrowded situations, and manage flow of people through an airport journey to, again, minimize that interaction with humans and machines. So that would be the ultimate goal of an airport environment, is to not touch anything and to not become in the proximity of another human by mandate of traveling through that system. And then you get on an airplane, so you're boarded in a much more controlled manner that we're used to seeing historically. And there'd be 3 areas that you focus on here: making the airplane something you didn't have to touch where you could. So, think about lavatories. No reason that a lavatory and an airplane can't be completely touchless. We see that on the ground, so why isn't that applicable in the airplane? No reason why you couldn't interact with a seat in business class in a touchless way through your own device. No reason why we couldn't manage queuing for lavatories in a touchless manner. No reason why you couldn't interact with the IFE in an airplane in a touchless manner. So focusing on areas where we can avoid touching. And then where we can't, focus on how we manage the pieces of the airplane that you have to touch. Obviously a seat, obviously a tray tabletop, a window shade if you haven't got a 787. But how do we treat those materials? How do we make those materials antimicrobial? How do we clean those materials? And how do we test that those materials are retaining their antimicrobial qualities? And then finally, the cabin environment. How do you control the atmosphere in an airplane using things like near UV lighting? There's lots spoken about the dangers to the human being of UV lighting. That is obviously true with the 405 UV, but there are other near UV lighting solutions that are proven to kill viruses and bacteria. So how do we use lighting to control the cabin environment? And then finally, the air management side of things. Obviously, at Collins, we're involved in air cycle machines and HEPA filtration. And so how do we spend time on cycling of air, filtration and decontamination? How do we focus on things like humidity? Because humidity in an aircraft is obviously very low. If it was like it was on the ground, your immune system would be far enhanced. And then biodetection finally. So, I often think about, if you're as old as I am, you used to watch Star Trek and they'd have that shuttle that go down to a planet and it would survey the atmosphere and it's all clear and the passengers would go onto the planet. Well, this is the same in reverse. It's not all about the fear of flying, it's all about the fear of the system. So when I arrive somewhere, am I actually able to go into that country? Am I actually able to do what I would like to do in that country without a quarantine period? So if I could bring an airplane full of passengers and assure the receiving airport that there is no COVID-19 in this instance in this airplane, would that change that whole environment of how we interact with the countries we're going to? So there's many, many things that we can think about as an industry and advance, but we've got to do it with these foundations in mind. So obviously technology, we're not going to reinvent the wheel. Technologies exist that we see in our day-to-day lives on the ground. We've got to bring them to the ecosystem of air travel. Proven efficacy. This is an absolute key, that we can, with substantive data, prove that whatever we've done has moved the needle on avoiding the spread of any pandemic. COVID-19 today, there'll be one tomorrow. There were ones in the past. Cost and installation. Obviously, you can't take an airplane out of service for any material amount of time to do any of these updates. And as I say, don't violate the fundamentals of operating an aircraft. Ease of operation. We've got to do it with ConOps in mind. And as you think about every one of these ideas, to think about reversing the middle seat in a cabin and putting a perspex shell around it doesn't, in the real world of ConOps, in terms of cleaning on turnaround, certification of a aft-facing seat. There's lots of things that would be headwinds to actually pulling that off. I saw an elbow-operated door handle on a lab, and the first thing I thought about was the first backpack going past it and ripping it off the wall. So we've got to make sure we do things that are actually things we can live with, because we're talking about changing how we operate our airplanes. And then the awareness. How do we keep passengers aware of the work that we're doing and sharing the experiences of actual pandemic avoidance? So really,
thank you very much, Colin. We're going to have to pause
okay, well, thank you.
We're running a bit over.
That's it. I was just at the end.
Really appreciate that. Some really great points there. Thank you very much for coming on. So lastly, we've got some last presentation from Ben Bettel, and then obviously we'll move over to our breakout sessions, which are slightly delayed. So we'll still have the full hour for most of them, and we'll run over into the wash-up session, which should be okay. So we'll have a good amount of time with our panels. So over to Ben, who's going to talk about the state of the nation for aircraft interiors in the context of the current climate.
Thank you very much, Will. I hope you can actually see the lead slide of my presentation. Let me explain a little bit about Counterpoint Market Intelligence. Counterpoint have been in business about 16 years, and we've been writing an interiors report now for 7 years. It started very small, and now it's a 500-page plus report that we issue about every October, November of each year. And it's about this kind of time that we speak at a number of events, and I started something that I called the State of the Nation. And for the last 5 or 6 years, I've only been talking about things, the needle going up, and unfortunately this year I'm starting to talk about the needle that has gone down. So a little bit sad, but anyway, some of my slides are not great news. Some of them you're probably already aware of, but I just wanted to explain a few things of how we look at the world when we're researching for our reports, and how we actually talk to real people, and both in airline and OEM as well as the manufacturing sectors to get an understanding of what is actually going on in the world. So we actually believe that because of the fleet inactivity, wide body with international carriers, we think it's going to continue all the way through 2021. There's probably going to be a second or third wave from what we understand. In fact, the UK is already reporting a second wave is happening. And as a result of this, it's going to affect our UK manufacturing sector quite seriously globally. Average load factors for July and August 2020, as a lot of people are already aware, was blended at 60.9%. In 2019, it was 85.3%. And the one that's really important to actually look at is really the year-on-year change on ASMs. It's down 70.7% according to our calculations and understanding. And the Chinese domestic travel has already recovered to near 2019 levels. I understand from our own person that we employ who's Chinese national, that they will be at 100% levels by the end of this year is the expectation. The one thing that we keep looking at is actually the number of aircraft that are on the ground. And you may wonder why I look at that. But at the moment, there's 650 aircraft on the ground that were retired from service this year. However, given that there's 4,500 in total that have been taken out of service, the real picture we don't think is going to emerge until all those parked and stored aircraft start to return to service, and how many are actually going to be left in a retired condition. Based on a worst case assessment globally, we'd expect also that there's likely to be a significant number of reductions in airlines or mergers about to happen over the next 6 months. So a little bit of facts and data here. So some airlines are still taking, this is for the supply chain, some airlines are still taking contractual OEM and retrofit orders. But also we understand from talking to a number of airlines that they've also issued stop work notices to their supply chain, which is really quite sad. And so historically, we have always seen, and I've been in the industry for, in the interiors industry for just coming up to 40 years, we've always understood there's a consistent relationship between new build aircraft manufacturing rates and the retrofit activity. Just for the people that are not aware too much about the interiors industry, interiors are unique, aircraft interiors are unique because there is a life after supplying the first interiors equipment in the form of retrofit. Retrofits depend on the type or element of the product in the aircraft. Seats, for example, can have a cycle of anywhere between 8 and 12 years before they're replaced. They're a little bit like fashion, that certain ideas, typically of what Martin come up with on the dust product, actually drove a 5,300 seat retrofit. So the retrofit activity is very important to the interiors industry. And that relationship with the new build aircraft, if there's less new build aircraft going through from the OEMs, that means the airlines are not taking the new aircraft. They're not making their older aircraft look like the new ones that they're receiving. And so the retrofit world actually gets affected. So we're seeing as a consequence of that, that the estimates for this year, that the manufacturing industry is going to be down about 51% from last year's figures, which is about half of what was actually manufactured. But in 2021, we're expecting that the retrofit activities are actually going to be reduced by even further. So whereas at the moment retrofit matches about 50-50 between new build and retrofit, we believe it's going to be about 40 to 35% down on this year's figures. So not good news for the industry. As a consequence of that, we're likely to see some supply chain company failures. I think it's inevitable. There's too many firms chasing a small amount of business. For example, just in the seating world alone, there's 33 companies that are actually manufacturing seating globally, all chasing a much smaller marketplace. There's one thing that we really do believe in that is likely to happen. The OEMs need critical supply chain organizations to remain in business. Colin mentioned lavatories, there's obviously galleys, there's obviously seating. And we see that the OEMs probably are getting quite concerned about the fact that these company closures could mean that their supply chains will be effective, or they've got less choice, or there's less SFE or BFE available for them to install. So we think the OEMs will not buy into companies, but will encourage the big to get bigger, which is something that we'll probably be using in a number of events, discussions in the future. Leasing companies, they've got 50% of the commercial aircraft flying in the world approximately are all owned by leasing companies. And leasing companies that we've been talking to have indicated they've experienced that 60 to 80% of their customers are requesting deferrals of payment. So that tells you that airlines obviously are not earning or generating sufficient revenues, and they're like, if you were a landlord, you're going to be asked for, if your lessor is actually asking for a payment holiday or a payment deferral. So the one thing that is quite noticeable as well is that we see that the pot of money that's called the maintenance lease maintenance reserve, that actually is at the end of the aircraft lease that the aircraft lease companies actually have. We see that that's not going to be spent on an aircraft if it's returned from lease until they've got a cast iron opportunity to actually release that particular aircraft. So that means it will remain parked. Again, that affects the retrofit kind of world as well. But there is good news, in my opinion. People I talk to, there is some shining light coming through. Obviously, there are pockets of activity. And like in any part of our life, if somebody's hungry for work, you can generally get some really good business deals. And so I think there will be some smart organization taking commercial advantage of a market that's struggling. So I think that's going to happen. In the short term, COVID-related activity will thrive with things such as antimicrobial materials, certification engineering that's required to meet those antimicrobial changes. And I think that's going to come out in the future, that many of these antimicrobial materials, plastics, cloths, and leather materials are going to be incorporated, and designs are going to be incorporated into new products when business normalizes. The wide body market's already been weakening, and I'm afraid it's a bit of a knockout blow that the 747-400s and the A380 passenger aircraft are not being used in high numbers anymore as a consequence of lack of international travel. But
just a 1 minute warning, Ben.
Thank you. But the decline of the wide body market will fuel some long range single aisle growth. So we see some great opportunities there regarding south seats, that's single aisle lie flat seating, PRM friendly interiors, which we cover in our report anyway. So Counterpoint believe that the interiors market will not return to 2019 levels until 2023, 2024. And we think that will only happen if there is available supply of global vaccine. Anyway, thank you very much, everybody, for listening. I hope I met the minute then.
Thank you very much, Ben. A great way to wrap up the state of the aircraft interiors nation. Thank you all. Thank you to all of our speakers. So I won't list them all. I'm not going to remember them all, but they're all really good and really diverse. Brought a great breadth of perspective. So now we move on to our breakouts, slightly delayed as potentially expected. Yeah, we were ambitious. So please click on the relevant link, either Excited to Fly or End-to-End Sustainability. The panelists are there ready, and we will kick that off as soon as possible. And obviously we'll try and make up the time and commit a full hour to each of those. So yeah, see you over there in just a second.